Today's topic is frequency hopping, presented by Professor Samir Bagban. Frequency hopping outline are as follows. Basics of wave spectrum. Frequency hopping spread spectrum. Block diagram and working of slow frequency hopping transmitter. Block diagram and working of slow frequency hopping receiver. Graphical view of frequency hopping using MFSK. Now we will see basic of wave spectrum. What can be gained from the apparent waste of spectrum? Immunity of the various kinds of noise and multiple distortion can be used for hiding the encryption signal. Several users can independently use the same higher bandwidth and very little interference. Now we are going to see frequency hopping. Signal is broadcasted over a seeming random series of radio frequencies. A number of channel is allotted for the frequency hopping signal. Width of each channel corresponds to the bandwidth of the input signal. Signal hops from frequency to fixed interval. The transmitter operates in one channel at a time. Bits are transmitted using some encoding schemes. At each successive interval, a new carrier frequency is selected. Red spectrum have some more points. Channel sequence detected by spreading code. Receiver hopping between frequencies in synchronization with transmitter picks up message. The block diagram of frequencies. Now, here the binary data is given to the modulator. Product modulator is having another input from the frequency synthesizer. From that channel table is provided with a pseudo-random noise, and this all together is having frequency hopping spreader. With the output is given to the bandpass filter, which is giving an output of spread spectral signal. You can see transmitter. The binary data are fed into the modulator using a DAC encoding such as frequency shift key and binary phase shift key. The signal is S suffix D. The pseudo-random noise source serves as an input into the table of frequency. This is spreading code referred to previously. Each k bits of the PN sequence specifies n k raised to n frequencies. Successive interval new carrier frequencies is selected. The frequency synthesizer generates a constant frequencies whose frequency hops amongst a set of 2 raised to k frequencies. The hopping pattern determined by k bits from the PN sequence. This is known as spreading or chipping signal, C of T. The most important, the bandpass filter is used to block the different frequencies and pass sum of frequencies, which is S of T. Diagram of FHSS receiver. The spreaded signal is received and is given to the T spreader, that is demodulator, is having frequency synthesizer, channel table, and most important, that is pseudo random noise, the same as that of your transmitter. The bandpass filter is given and the demodulator of FSK and BPSK is used, and we get regenerated binary data. Working of FHSS receiver. The same sequence of PN frequencies is used at the demodulator to produce the output data. At the receiver, the spreading signal from the transmitter S of T will be received. This is multiplied by a replica of spreading signal to yield the product of signal. The bandpass filter is used to block the sum frequencies and pass the different frequencies which is then demodulated to recover the binary data. Graphical view of slow frequency hopping. we have FSK, which is having input data and frequency sense. This is the frequency slot which has been appeared, and the data which has been selected by an arrow is shown, that is 0, 1 and 1, 1. Nextly, it will jump to the next frequency slot, that is 1, 1, and the data is 0, 0. So initially it is starting, and then the data is 1, 1. So what would be the next frequency hopping will be produced? Question arises, what would be the next frequency hopping pattern in the figure above? You might have got an idea where the next frequency hopping is going to take place. As the next frequency slot is 0, 1, the shaded portion is highlighting, and the data are 1, 1 and 0, 1. As the name says that it is low frequency, data is hopping in the same frequency slot. You can observe this same thing in the next frequency slot 1, 0. The data is 1, 0 and 0, 0, which is all shuffling in the same frequency slot. In the same way, at the frequency slot 0, 0, the data is 0, 0, 0, 1. Even though data are different, but they are varying in the same frequency slot 0, 0. Review of slow frequency hopping. You can observe that your frequency slots are being highlighted with a brown color, and your data is being highlighted with a blue color, which are in the same frequency slot. Some of the significance of frequency hopping, like immunity to jamming, low interference, high performance gain, easy encryption, greater security, and multiple access, that is CDMA technique.